Hello, this will be a demonstration of proposition 18 from book 3 of Euclid's Elements, which states that if a straight line touch a circle and a straight line be joined from the center to the point of contact, the straight line so joined will be perpendicular to the tangent straight line. We are given the circle ABC, like so, ABC, and we are given the straight line DCE, like so, such that DCE touches the circle ABC at the point C. We are also given the center of the circle ABF, or ABC, as point F. And we are given the straight line FC, which joins the center and the point of contact. And what we're going to prove is that FC is perpendicular to DE. Now, if this is not the case, if FC is not perpendicular to DE, then there must be some other straight line through the point F such that it is perpendicular to DE. Well, we'll then make such a straight line and we'll call it FG, okay? From the point F, we shall make FG perpendicular to DE. We can do this by proposition 112. Now we know that the angle at G, the angle FGC, is a right angle. This angle right here must be a right angle because we made it that way. We made FG perpendicular to DE. And we also know by proposition 117 that if you take any two angles in a triangle and add them together, the sum must be less than two right angles. And so we can say that the angle FGC plus the angle FCG is less than two right angles. And the only way that this can work out if one of these angles simply is a right angle is that the other one is less than a right angle. And so we can say that the angle FCG is less than a right angle. And furthermore, by proposition 119, that the greater angle is subtended by the greater side, we have the angle FGC greater than the angle FCG, and so the side subtending FGC must be greater than the side subtending FCG, so that we can say that FC is greater than FG. Now we also know by definition 115 that because FC and FB are radii of the same circle, then they must be equal. And so FC is equal to FB. So by a property of magnitudes, we can say that FB must also be greater than FG. If FC is greater than FB and FC is equal to FB, then FB is greater than FG. So we have that FB is greater than FG, but we can also see that FB is a part of the straight line FG. And so we know that FB must be less than the straight line FG by common notion 5. And so FB must be simultaneously greater than and less than the straight line FG, which is absurd. And so we can say that there is no straight line but the straight line FC perpendicular to DE at the point C. This being what we set out to prove, we are done with the proposition, therefore, etc. Q, E, D. I have nothing to say about this proposition, so I shall move on to 319.